Imagine a cosmic symphony performed by an incalculable number of stars, planets, and moons, all playing in perfect harmony. Amid this orchestral expanse lies a particularly mysterious section that has left astronomers perplexed for centuries: the exoplanets. These distant worlds are not merely celestial bodies. They are enigmatic puzzles scattered across the vast depths of the Milky Way, each one a potential revelation. Among the billions upon billions of cosmic objects, one exoplanet stands out as an extraordinary anomaly, so uncannily similar to Earth, so tantalizingly familiar yet fundamentally mysterious that it has often been referred to as Earth's celestial twin. This world is known as Proxima b, located a mere 4.2 light-years away from us. It has captivated scientists and dreamers alike with its potential. Now, with the advent of the James Webb Space Telescope, our pursuit of understanding such alien worlds is undergoing a monumental transformation. Picture your imagination soaring through the colossal expanse of the Milky Way, a galaxy that is home to more than a quadrillion exoplanets. To grasp such an incomprehensible number, imagine 1 quadrillion grains of sand. Not only could they fill the Grand Canyon, but they could form an entirely new geological monument altogether. A Grand Canyon 2.0 stretching across the landscape for miles. Even more astonishing is that nearly 20% of these exoplanets are considered Earth-like in terms of their atmospheric and geological composition. Statistically, that means 1 in 5 of these planets could potentially resemble our own, a staggering thought. Alongside them orbit a similarly overwhelming number of moons, rocky satellites like our own engaged in elegant gravitational dances with their parent worlds. If one were to place a wager on the likelihood of discovering another celestial body capable of supporting life, the odds would be overwhelmingly in our favor. Now that we have drawn open the curtains on this vast cosmic theater, it is time to introduce the masterful instrument that allows us to observe its intricate details. The James Webb Space Telescope. Think of it as a celestial Sherlock Holmes, not wielding a magnifying glass, but a massive 6.5 meters primary mirror, which is 2.7 times larger than Hubble's. With its unprecedented sensitivity, it can detect the faintest flickers of light from stars billions of light-years away and analyze the chemical fingerprints of exoplanets orbiting them. Its revolutionary technology includes cutting-edge infrared sensors and a powerful spectrograph that do far more than observe. They interpret the symphony of cosmic signals. The Webb telescope doesn't merely witness the universe. It deciphers it. Its ability to filter and read the unique light signatures emitted or reflected by celestial bodies enables it to determine atmospheric composition, mass, and even the potential for habitability. In many ways, the James Webb Space Telescope represents a quantum leap in astronomical exploration. A step forward that has forever changed our capabilities in the quest to understand the cosmos. Amid this grand narrative, our focus narrows once again to one specific world, Proxima b. Since its discovery in 2016, this enigmatic exoplanet has taken center stage like a Shakespearean protagonist filled with contradictions, drama, and tantalizing possibilities. The fascination with Proxima b begins with its proximity. Located just 4.2 light-years from Earth, it is essentially in our cosmic backyard. To offer perspective, if humans could travel at the speed of light, a feat well beyond our current technological reach, it would take just over 4 years to arrive at Proxima b. That's roughly the duration of a presidential term, or the time it takes for your favorite television series to undergo a radical transformation. In a universe that stretches over 93 billion light-years across, the discovery of a potentially habitable planet so close to Earth is nothing short of extraordinary. It is akin to finding a rare diamond shimmering with potential in the middle of an endless desert, but it's not just the proximity of Proxima b that excites the scientific community. It's the possibility that this planet, under the right conditions, could serve as a second Earth. Proxima b orbits within its star's habitable zone, often called the Goldilocks zone, where conditions are just right, not too hot, not too cold for the presence of liquid water. A vital ingredient for life as we know it. Imagine waterfalls cascading down alien cliffs, winding rivers meandering through extraterrestrial valleys, or oceans as deep and mysterious as Earth's Mariana Trench. However, before we start planning interstellar vacations, there are peculiar characteristics to consider. For instance, a single day on Proxima b lasts about 11 Earth days. This means sunrises would stretch across hours with golden dawns lingering far beyond what we know, and sunsets would seem painted into the sky, slow to fade. Such prolonged cycles of light and darkness could have profound implications for climate, weather systems, and human biology. Could our sleep patterns, eating habits, or work schedules adapt to such an alien rhythm? Would our minds and bodies find harmony or chaos in this strange new environment? On Proxima b, the familiar would coexist with the alien in ways that challenge our understanding of life itself. You might wonder how scientists have gathered such detailed information about a planet we've never physically visited. This is where the James Webb Space Telescope flexes its extraordinary muscles. More than just a distant observer, Webb is a floating scientific laboratory. Through its spectrographs, it analyzes the light emitted or reflected by distant worlds. Every atom and molecule interacts with light uniquely, absorbing or emitting specific wavelengths. By examining these light signatures, scientists can determine whether an exoplanet possesses water vapor, organic carbon-based compounds, or even oxygen, elements that are fundamental to life as we understand it. This is not merely astronomy. It is forensic science conducted on a cosmic scale. No longer do we wait for the universe to reveal its secrets. We now actively search for them, dissecting photons like galactic detectives. In this regard, the James Webb Telescope is a perfect hybrid of laboratory analyst and cosmic sleuth. Then, just when it seemed that the exploration of Proxima b was yielding gradual progress, an astonishing twist unfolded, one that would feel right at home in the most gripping science fiction epics. Using the Webb telescope, researchers detected a signal from Proxima b that was so strange, so anomalous in its complexity that it sent shock waves through the scientific community, classified as a potential technosignature. This electromagnetic signal displayed patterns suggestive of an artificial origin. For a fleeting moment, the collective imagination of humanity was suspended in awe. Could this finally be the confirmation we've long awaited that we are not alone in the universe? And just as suddenly as it had appeared, the signal vanished. It was never repeated. Regardless of the answer, that moment redefined our understanding of Proxima b. No longer was it just another exoplanet under observation. It had become a symbol of the ultimate cosmic mystery. The questions raised by that fleeting signal remain unanswered. Was it a technological error, a trick of instrumentation, or a glimpse into a more complex cosmic narrative? The truth remains elusive, yet the story is far from over. The final chapter has not yet been written, and the ink is still wet. The narrative of our cosmic exploration is an evolving tapestry, and new players are stepping onto the stage. Researchers from Harvard and other leading institutions are collaborating to unravel this mystery using advanced algorithms, new observational strategies, and deeper spectral analyses. They are crafting new pathways toward understanding what or who may be out there. In the end, the story of Proxima b transcends the boundaries of planetary science. It is a reflection of how we see ourselves in the cosmos. It speaks to the questions we dare to ask, the tools we invent, and the endless curiosity that compels us to look up at the night sky. Thanks to the James Webb Space Telescope, we are no longer just passive observers. We are participants in a celestial dialogue. Perhaps, just perhaps, the universe is beginning to whisper back, The obsession surrounding Proxima b has shifted from scientific curiosity to something far more profound. This is not simply about atmospheric data or orbital mechanics. It's about identity, possibility, and hope. What if Earth isn't unique? What if life is not an anomaly, but a recurring theme across the galaxy? The Webb telescope has given us not only a lens to observe, but the instruments to investigate with extraordinary clarity. Through its capabilities, astronomers have begun to detect subtle chemical traces in the light spectrum from Proxima b, suggesting the possible presence of water vapor and carbon-based compounds. These two pillars of organic life have not confirmed biological activity, but they make Proxima b a prime candidate for deeper exploration. The implications are staggering. If even one exoplanet like Proxima b can support life, the statistical probability of life elsewhere in the universe skyrockets. After all, if life arose once on Earth under very specific but not rare conditions, then it may have emerged again, perhaps frequently on worlds with similar environments. The universe, rather than being a cold, sterile void, may in fact be a fertile garden of potential teeming with the seeds of life. But the mystery doesn't stop at atmospheric analysis or even at the Goldilocks zone. That strange, ephemeral signal detected by the James Webb Space Telescope reignited discussions around technosignature's evidence that might indicate intelligent life, such as radio waves, bursts of controlled energy, or highly organized electromagnetic emissions. While many scientists remain cautious about jumping to conclusions, they universally agree that anomalies demand investigation. What forms might extraterrestrial life take? Would it resemble us carbon-based, water-dependent, tool-using, or would it be something entirely unfamiliar with forms of intelligence beyond our current comprehension? Even if Proxima b currently harbors no life, its significance cannot be diminished. Some researchers propose that the planet may be in a transitional state, either on the cusp of developing life or in the aftermath of an extinction event. Imagine a world where evolution took a divergent path, where unfamiliar organisms once thrived but were later wiped out by cosmic or environmental cataclysms. Traces of such life might still linger in its rocks, its soil, or its atmospheric chemistry. Studying Proxima b could teach us not only about other worlds, but about ourselves, about life's resilience, its fragility, and its astonishing ability to adapt to even the most foreign and extreme environments. The possibilities orbiting around Proxima b extend far beyond mere scientific curiosity. They tap into the very soul of human wonder and the timeless question of whether we are alone in the cosmos. While concrete evidence of life remains elusive, the intricate clues continue to fuel speculation and hope. Proxima b stands not merely as a physical object in space, but as a powerful symbol of potential and of science's boundless capacity to push the limits of understanding. As more data streams in from the James Webb Space Telescope, astronomers are refining their models of Proxima b's atmosphere and surface. They've detected subtle fluctuations in starlight that hint at weather patterns, perhaps even cloud cover, or atmospheric circulation. Sophisticated simulations attempt to reconstruct how heat from its host star, Proxima Centauri I, might distribute across the planet's surface, especially if Proxima b is tidally locked, presenting the same face to its star at all times. In such a scenario, one hemisphere would bask in perpetual daylight while the other would be cloaked in eternal darkness, leading to extreme climate dichotomies. And yet, even in these harsh conditions, life could conceivably adapt. Microbial life might exist in the temperate twilight zone, the narrow strip where day and night meet, where conditions might be more stable. Moreover, questions about magnetic fields and radiation further complicate the portrait of Proxima b. Proxima Centauri is a red dwarf star notorious for violent flares and bursts of high-energy radiation. These stellar tempests could strip away a planet's atmosphere or bombard its surface with radiation hostile to unshielded life. But what if Proxima b possesses a strong magnetic field like Earth's? Such a field could deflect harmful particles and preserve its atmosphere, dramatically increasing the chances of habitability. Some scientists have proposed that life on such a planet might evolve underground or in its oceans, using water or rock as natural barriers against radiation. These hypotheses underscore just how varied and how hopeful the vision of life in the universe has become, continuing our journey through the remarkable possibilities offered by Proxima b. We find ourselves at the frontier of discovery where science, imagination, and philosophy converge. The more we peer into this enigmatic world, the more we realize that the questions it raises are as important as the answers we seek. At a distance of just 4.2 light years, Proxima b is close enough to tempt serious consideration of future exploration, whether robotic or, in the far future, even human. Its proximity makes it a prime candidate for interstellar missions, and ambitious initiatives like Breakthrough Starshot are already envisioning ways to bridge the vast cosmic gulf between our worlds. These projects propose launching tiny, laser-driven spacecraft capable of reaching Proxima Centauri in just a couple of decades. If successful, they could capture close-up images of Proxima b and perhaps even study its atmosphere directly. Such missions would mark a turning point in our species' journey from stargazers to interstellar explorers, transforming the dream of reaching another star system into a reality. In the end, the search for understanding Proxima b is about much more than a single exoplanet. It is about our desire to know if we are alone, our willingness to ask the hardest questions, and our relentless quest to find our place in a vast, mysterious cosmos. It is a testament to human curiosity, our most defining and enduring trait. As long as Proxima beckons from the depths of space, we will continue to seek answers, to dream, and to push the boundaries of what we know. The universe is vast, but so too is our determination to explore it.